Hey everyone, so I've got a book coming out later this month. You can check it out or pre-order it in the description below. Welcome to another Cold Fusion video. Nanobots. You may have seen them depicted in movies like Big Hero 6, but recently they're becoming a reality, although not in the form that you would expect. In this video, we'll take a look at what they are and the promise that they hold in the context of biotechnology and some of the latest research happening around the globe.
You are watching Cold Fusion TV.
The research suggests that nanobots could assist medical professionals in complex tasks after passing through tiny spaces in the human body. One of the biggest potential applications is for extremely targeted drug delivery to specific cells within the body. As we'll soon see, this has already been achieved. Scientists also believe that nanobots could be used to reduce plaque in veins, solve dietary issues, along with a whole slew of other medical uses. They'll be able to operate in parts of the body where the blood flow is slower, such as capillaries in the eye or fluids outside the circulatory system, such as ventricles of the brain or urinary tract. So all of you have probably heard of CRISPR gene editing. Although not directly related, CRISPR is an offshoot of the nanobot idea. CRISPR is actually an exploitation of a natural molecular DNA function. Scientists use a virus's natural ability to cut and splice the DNA we want to edit at will. We've talked about CRISPR DNA editing in the case of destroying cancer in a previous video. I'll leave it in the description below so you can open it in a new tab. We'll take a closer look at DNA nanobots in a second, but first, let's delve into where this idea came from in the first place. It's older than you might imagine. The origin of nanobots is commonly attributed to Richard Feynman, a scientist in the Manhattan Project, the man behind the theory of quantum computers, and a pivotal mind in quantum physics. Feynman solidified his idea in his 1959 writing, "There's plenty of room at the bottom." In it, Richard Feynman imagined a day where machines could be miniaturized and huge amounts of information could be encoded in minuscule spaces, paving the way for disruptive technological developments. The technology would be so good that it could, quote, swallow the surgeon, as he put it. So what is nano? Nanotechnology is the science, engineering, and technology conducted at the nanoscale, which is about 1 to 100 nanometers. Let's put that into a perspective. The ratio of the Earth to a marble is roughly the same ratio as a meter to a nanometer. A nanometer is 1,000,000 times smaller than the length of an ant. A strand of DNA is 2.5 nanometers in diameter, making them the perfect candidate for a basis for nanorobots. There's a couple of types of nanobots in existence today, but right now we'll focus on those made from DNA and those that are man-made. So let's take a look at the state of the art. Researchers at the University of San Diego developed nanorobots capable of cleaning toxins from blood generated by harmful bacteria. These nanorobots are about 25 times smaller than the width of a human hair and are made from a combination of natural red blood cell and platelet membranes and artificial gold wire. They can be controlled by ultrasound, which eliminates the need for a battery during propulsion. While still experimental, early tests have proved successful, with nanobot-treated blood containing 3 times less toxins and bacteria than untreated blood. The scientists note that, quote, this is a proof-of-concept platform for diverse therapeutic and biodetoxification applications, end quote.
By using this natural biomaterial membrane, coating our microrobot, we can impart new functionality, new capability like removal of pathogen and toxin from the body.
Researchers at the Arizona State University and the National Center for Nanoscience and Technology of the Chinese Academy of Scientists injected nanobots made from a folded sheet of DNA into the bloodstream of mice. To perform their study, first, scientists induced aggressive tumor growth in the mice. Once the tumor was growing, the nanobots were deployed to come to the rescue. Each nanobot is made from a flat, rectangular DNA sheet 90 nanometers by 60 nanometers in size. A key blood clotting enzyme called thrombin is attached to the surface. Thrombin can block tumor blood flow by clotting the blood vessels that feed tumor growth, essentially leading to the tumor's death. First, an average of 4 thrombin molecules were attached to the flat DNA scaffold. Next, the flat sheet was folded in on itself like a sheet of paper into a circle to make a hollow tube. These were then injected via IV into a mouse. The The nanobots then travel through the bloodstream, homing in on the tumours. The key to programming a nanobot that only attacks a cancer cell was to include a special homing device that specifically targets a protein that is made in large amounts on the surface of tumour cells. The thing is, this protein is not found on the surface of healthy cells. The result is a DNA device that seeks out tumour blood vessels and is programmed to release its blood-clotting cargo right into the heart of the tumour, killing it. The nanobots worked quickly, congregating in large amounts to surround the tumour just hours after injection. According to the scientists, this technology is a strategy that can be used for many types of cancer, since all solid tumour-feeding blood vessels are essentially the same. So here were the results. 3 out of the 8 mice receiving the nanobot therapy showed complete regression of the tumours. The median survival time more than doubled, extending from 20.5 days to 45 days. Healthy tissue was left untouched, and I think this is pretty good for such an early trial. They also tried their system with lung cancer. The tumour tissue showed shrinkage after 2 weeks of treatment. Professor Hao Yan, one of the lead researchers, weighs in with his thoughts. I think we're much closer to real, practical medical applications of this technology. Combinations of different rationally designed nanorobots carrying various agents may help to accomplish the ultimate goal of cancer research, the eradication of solid tumours." End quote. Yan and his collaborators are now actively pursuing clinical partners to further develop this technology. A nanobot device is roughly the size of a red blood cell or smaller. This is too small to add elements like a motor, computer chip, or camera, so bioengineered bots made from DNA are a common platform for such medical tasks. But as you'll see next, nanobots made from man-made materials are possible and are currently being used in research right now. So here we come to our featured story, which was the inspiration for this video. Not long ago, I was contacted from someone from the Max Planck Institute in Stuttgart, Germany. The team behind this next story has done a world first, this time using nanorobot vehicles instead of DNA. These were the first nanobot robot vehicles steered in real dense tissue, a pig's eye in this case. Usually, these tiny vehicles navigate through artificial demonstrational biological liquids, not real tissue. The bots were made out of iron spirals that would swim under the presence of a magnet. The trick and the breakthrough was a special double coating that allowed for the bots to swim freely without damaging the surrounding tissue. The hope is to one day incorporate a drug delivery system into these devices.
So what is the vision for this nanopropeller? What do you hope it can do one day?
So the vision of these nanopropeller is that one day we will load drug to the nanopropeller and they will carry these drugs and propel through the vitreous to the retina and release drug very locally in a targeted way. Yeah, so this is the first time that we demonstrate it is possible to use these nanorobots to really penetrate real biological tissues.
So what does the future hold? Well, there's a lot of activity going on in this space. Scientists at MIT have recently developed optically powered, batteryless nanobots equipped with sensors able to record and monitor chemicals like enzymes and hormones. The information can then be downloaded and analysed. The study has been hailed as a completely new field of robotics. Further to this, the California Institute of Technology are throwing their hat in the ring. They're developing DNA robot toolkits that are being created to allow medical developers to use them in building more capable DNA robots. The device is made from a single strand of DNA that can autonomously navigate around a surface, pick up certain molecules and drop them off at predetermined locations. The California team used a DNA nanobot to successfully sort 6 scattered molecules into their pre-assigned places in 24 hours. Adding more robots would reduce the time needed to complete tasks. Lulu Quian, assistant professor of bioengineering, comments, quote, "It is my hope that other researchers could use these principles for exciting applications such as DNA robot for synthesizing therapeutic chemicals from its constituent parts in an artificial molecular factory, delivering a drug only when a specific signal is given in bloodstreams or cells, or sorting out molecular components in trash for recycling," end quote. For some reason, it reminds me of open source development kits which other programmers can build off. This pattern of building off others is very commonplace wherever there is exponential scientific development. Okay, so let's recap. So we have DNA robots that can detoxify blood, other DNA nanorobots that can starve tumours, man-made nanorobots that can swim through dense tissue, tiny nanorobots that can sense its chemical environment within a body and relay that information to medical professionals, and a DNA nanorobot development kit. If we were to compare the current situation to the historical progress of computers, this would be like the 1960s when mini-computers were reigning. They were hard to use, limited to research groups, not quite a revolution, but they showed great promise. Or this could be like the internet of the 1980s, where online communities existed, but it was before the web, and it was still when people were figuring out how this was all going to work. Although it's early in its life cycle, the progress of nanobots is moving rapidly. Maybe in 10 to 15 years, nanobots will become commonplace addition to the field of biotech, that is, if a meaningful way to reduce the future cost is found. So that just about wraps up our look at nanorobots. Let me know what you think in the comment section below. So thanks for watching. This has been Dagogo. You've been watching Cold Fusion. If you've just stumbled across this channel, feel free to subscribe. I'm sure you'll find some interesting stuff around here. Thanks for watching, and I'll see you again soon for the next video. Cheers guys. Have a good one.
Cold Fusion. It's new thinking.